Hello and welcome to a video lecture on streams in C++. Every program takes some data as input, and that input will be processed, and later it will give you an output. So this forms an input process output cycle. It is therefore essential to know how to provide the input data and how to present the results in desired form. We have in the earlier classes studied about C in and C out operators with insertion and extraction operators which perform the input and output. C++ supports a bit set of IO functions and operations to do this. Since these functions use the advanced features in C++, we need to know a lot about them before really implementing them. So remember, C++ supports all C programming languages' rich set of IO functions. We can use any of them in C++ programs, but there are two limitations on using them. The first one being IO methods in C++ support the concept of object-oriented programming, whereas the IO methods in C programming language cannot handle the user-defined data types such as classes and objects. So C++ uses the concept of stream and stream classes to implement its IO operations with the console and disk files. Let us try to understand the streams, C++ streams. The IO systems in C++ is designed to work with variety of devices such as terminals, disks, and tape drives. The IO system supplies an interface to the programmer that is independent of actual device that is being accessed. And this interface itself is known as stream. So the basic definition of stream would be like this. A stream is a sequence of bytes. It acts either as a source from which the input data can be obtained, or it can also act as a destination to which the output data can be sent. The source stream that provides data to the program is called as input stream, and the destination stream that receives output from the program is called as the output stream. In other words, the program that extracts the bytes from an input stream and inserts bytes into an output stream. So that itself is being depicted here in this diagram. The data in the input stream can come from keyboard or any other storage device. Similarly, the data in the output stream can go to the screen or any other storage device. So as I've mentioned earlier, a stream acts as an interface between the program and the input-output device. Therefore, C++ program handles the data independent of the device that is being used. Now let us try to understand C++ stream classes. The C++ IO system contains a hierarchy of classes that are used to define various streams to deal with both console and disk files. So these are called as stream classes. Let us try to understand that hierarchy of classes. So here the base class is the iOS class, which is nothing but input output stream class. Okay, and it is being followed by three more classes, that is iStream class, OStream class, and IOStream class. So iStream here stands for input stream, O stream stands for output stream and IO stream stands for input output stream. The class iOS is declared as the virtual base class so that only one copy of its members are inherited by the IO stream. So in this diagram we can understand that we have an example for multiple inheritance where the subclasses, I mean the intermediate subclasses such as I stream and O stream are inherited from the iOS base class, whereas IO stream class is inheriting features from its base classes, that is iStream and OStream, and in turn those two classes are inheriting the features from its base class called as iOS class. Here the class iOS provides the basic support for formatted and unformatted IO operations. The class iStream provides the facilities for formatted and unformatted input, while the class OStream provides the facilities for formatted output. The class IOStream provides the facilities for handling both input as well as output streams. There are other three classes, namely iStream with assign, OStream with assign, and IOStream with assign, which will do the assignment operators. In fact, they will add the assignment operators to these classes. Now let us try to understand the various classes and their functionalities. So the first class, that is being the base class, is iOS class. It contains basic facilities that are used by all other input and output classes. It also contains a pointer to a buffer object called as stream buff, and this is used in accessing the files and all. It declares constants and functions that are necessary for handling formatted input and output operations. The next class is the iStream class, which is inherited from the iOS class. So it inherits all the properties of iOS class. It declares input functions such as get, getLine, and read and more. And it contains overloaded extraction operator that we oftenly use to get the input from the users. And the next class is the OStream class, which is again inherited from the iOS base class. So it inherits all the properties of iOS class, declares the output functions such as put and write, and it contains an overloaded insertion operator with which we try to print the output on the screen. And the next class that we see is the IOStream class, which inherits the properties from the iOS base class and two subclasses, namely iStream and OStream, through a multiple inheritance, and thus it contains all the input and output functions. And one more thing that we have seen is the stream buff. So stream buff is a class which provides an interface to the physical devices through the buffers. It acts as a base for file buff class used in iOS files. Let us try to understand some of the functions and flags that are provided in iOS, that is input output stream class, for modifying the output. Okay, so the first function here is the width function, which is used to specify the field size for displaying an output value. So with the help of width we can certainly display the output with the size that is being passed as the parameter. Next function is the precision, to specify the number of digits to be displayed after the decimal sign. Considering an example of a floating point number, let us say we are trying to print a floating point number with the number of digits after the decimal point being restricted to some number. So in that case, we can make use of this precision function to restrict the number of digits to be displayed after the decimal sign. On the similar lines, we have one more function called fill to specify a character that is used to fill the unused portion of a field. And we'll use two more functions. In fact, they are flags. The first one is the setF flag to specify format flags that can control the form of output display. Similarly, one more flag, that is unsetF, to clear the flags that are already specified. Let us move on and try to understand manipulators. So in general, what we can understand from manipulators is they are trying to manipulate something. So we can certainly manipulate the output that we are trying to print on our screen with the help of a header file called as iomanip. So this iomanip header file provides some functions called as manipulators, which will be used to manipulate the output formats. They provide the same feature as that of the iOS member functions and flags. Some manipulators are more convenient to use than their counterparts in the class iOS. Let us consider two examples here and try to understand how manipulators are used. So in the first statement, what I have done here is I am trying to print a data item, namely item, and I am trying to apply three manipulators, that is manip1, manip2 and manip3. So all these three manipulators can be applied onto a data item called as item. So all these three manipulators are certainly applied to the data item called as item in a chain. And in the second statement, again I am trying to print two different data items, namely item 1 and item 2, and I am trying to apply two different manipulators for two different data items. So for the first item, I am trying to apply the manip1, the manipulator 1, and for second data item, I am trying to apply manipulator 2. So in this way, I can chain more than one manipulators together, and I can certainly manipulate the output that I want to display it onto my output screen. So the most commonly used manipulators I have listed here. So the first one is set W, which is going to set the field width to be equal to W, or the size that I pass as a parameter. And set precision is going to set the floating point precision with the value that I pass as a parameter. And then set iOS flags, it is going to format the flag with the parameter that I pass, and certainly reset iOS flags does the opposite of what set iOS flags does, that is clearing the flag specified by the parameter that I pass. And one more is the endl, which is going to insert a new line and flush the string, which is similar to the operation that we used to do with /n in C programming. Likewise, we can find so many manipulators which can be used to manipulate the output in C++. Now let us try to understand with one example. So here I am trying to print a name called as Pritesh with a manipulator called as setW. So setW is used to set the field width to be equal to the parameter that we pass. So here I am passing 10 as the parameter. So the size of the output is 10, within which it has to display the character array, that is Pritesh. So the first three fields are kept blank and rest of the fields are occupied by the character array, that is Pritesh, to be equal to a total width of 10. So this is how set W will certainly manipulate your output so that the character array, that is Pritesh, will be displayed to be right justified. Let us move on and understand the ultimate concept, that is user defined manipulators, that is designing our own manipulators. So certainly we can design our own manipulators for certain special purposes. So the general form of creating a manipulator without any argument is given here, that is OStream followed by ampersand manipulator, and then I am passing a parameter called as output, and in the braces I'm trying to write the code that I would like to manipulate, and certainly I'll return the output. So for example, let us say I'm trying to write a manipulator called as unit. So whenever I'm trying to print a number, I should be able to attach a unit to that particular number. So how can I do that? So I'll just write a manipulator called as unit, in which I try to print inches as the unit, and I'll just return the output. Let us say I'm trying to print 36 inches. Then what I'll do is I'll say cout followed by extraction operator and then 36 and then followed by the manipulator that I have defined here. So directly I can call the manipulator using the extraction operator itself, so that whatever is written in the manipulator gets reflected here. So this will print 36 inches. Okay. So on the similar lines, I can write any sort of user defined manipulators and I can use them within the program. Okay. Thank you for listening to the lecture.